have different types. Previously we have classified into convex polygon, concave polygon, convex polygon, convex polygon. All the angles of polygon is less than 180 degrees. That means if you take any one of the angle is less than 180 degrees, so each and every angle of a polygon is less than 180 degrees, we call it is convex polygon. If at least one of the angle is greater than 180 degrees, then we call it convex polygon. So convex and concave we have discussed. Let's discuss about regular and irregular polygon. We have seen some of the diagrams, the pictures of square and rhombus, and this, all the sides are equal. So this kind of pictures, this kind of diagrams are called as regular polygons. For example, square, rhombus, what we have discussed. So what we understood from this is, if all the sides of the polygon is equal, then we call it as a regular polygon. If it is different, then we call it as irregular. So polygon, regular and irregular. Let's discuss about the regular polygon and irregular polygon. Regular polygon is that the square and rhombus irregular polygons are nothing but the different sides are there. Like if you take any one of it from the rectangle, is a rectangle. If it is like something we have taken like parallelogram or any kind of quadrilateral, and anything we can take. For example, we have written these names, so we can take different sides with the different sides, and then we call it an irregular polygon. Irregular polygon. These are formed with the different sides. So that is called regular polygon. The different sides it will form, and sides are equal sides. So equal sides. Equal sides. Regular polygon will form with the equal sides, and irregular polygon will form with the different sides. For example, this is example we have taken. So quadrilateral, rectangle, parallelogram, and different sides. Here, square, rhombus, and equilateral triangle. Equilateral triangle. So these are all called regular polygons because the sides of the polygon are equal. That's the reason. Let's see here. Let's say square. The square, all the sides are equal. That's the reason. Say regular polygon. This all the three sides of triangle are equal. Equilateral triangle. Rhombus. All the sides of rhombus are equal. And so that's a reason these are called regular polygons. So these different sides are formed. So irregular polygons. Let's go to the next concept. If you take any polygon with a number of sides, except a triangle, we are taking any quadrilateral. For example, for any polygon. For example, let us take a quadrilateral which is having 4 sides. If you join non-consecutive sides, non-consecutive vertices of this quadrilateral non-consecutive vertices A, B, C, D are vertices of quadrilateral, and this A and C are non-consecutive vertices, and B and D are also non-consecutive vertices. These are consecutive vertices, and immediately after what is followed, the vertex which is following, that are called consecutive vertices. These two are consecutive vertices. Non-consecutive vertices are these two. If you join this four non-consecutive vertices, the line segment, and what is the line segment is formed, that is called as diagonal. So CD is diagonal. So CD is called diagonal of quadrilateral, and if you join these two non-consecutive sides, BD, and this is also diagonal. So here the opposite vertices are joined together, or non-consecutive vertices are joined together, forms a diagonal. So two diagonals we got. Similar manner, we can join the non-consecutive vertices and the pentagon, hexagon, nonagon, and also so many things. So to find the number of diagonals of a polygon, we have one of the rule. That rule is n into n minus 1 divided by 2 minus 1. This is number of diagonals of a polygon. Number of diagonals of a polygon is n into n minus 1 divided by 2 minus 1. Let's see. Let's verify. This is how we get the number of diagonals we get for quadrilateral. So n is nothing but the number of sides of a polygon of that particular polygon what we have taken. So here the number of sides of this polygon is 4 because it's a quadrilateral. So we take 4 into 4 minus 1 divided by 2 minus 1, because this is the formula, n into n minus 1 by 2 minus 1. So the number of sides are 4, so into 4 minus 1 by 2 minus 1. So here 4 minus 1 is 3 by 2 minus 1. So you know that here first we need to cancellation. So let's cancel this to 1 time, this 2 times. So 2 into 3 minus 1. So the number of diagonals of a polygon, we have one of the rule. The rule is n into n minus 1 by 2 minus n. The number of diagonals of a polygon, want to find out, we introduce this formula, n into n minus 1 by 2 minus n. N is nothing but number of sides. So we have already discussed. So that is n is, here we have taken quadrilateral, and this quadrilateral we have 4 sides. It's 4 into 4 minus 1 by 2 minus 4. So 4 into 3 by 2 minus 4. With the cancellation, we get here 2 times 2 into 3 minus 4. That is 6 minus 4 is 2. So the number of diagonals in the quadrilateral, which is having 4 sides, and it's 4. If it's having 4 sides, then diagonals will be 2. Already we have diagonals 2. So let's prove that the number of diagonals, the formula is n into n minus 1 by 2 minus n. So up to now we have discussed about the polygons and its diagonal and the number of diagonals of polygon. Quadrilateral, a simple closed figure which is bounded by 4 line segments is called as quadrilateral. Here we have different types of quadrilaterals that we are taking which is having 4 four-sided figure. In that, one of the pair of opposite sides are parallel. We call it as trapezium. You see this picture? It's a quadrilateral, and in that, one pair of opposite sides are parallel. In a quadrilateral, then it becomes a trapezium. One pair of opposite sides are parallel. In a quadrilateral, then it becomes a trapezium. In a trapezium, if non-parallel sides are equal, then we call it as isosceles trapezium. Non-parallel sides are equal. This is opposite sides. One of the opposite sides are parallel to each other. So these are non-parallel sides. If non-parallel sides are equal, we call it as isosceles trapezium. Trapezium becomes isosceles trapezium when non-parallel sides become equal. So what we have understood here, four-sided figure is called quadrilateral. And a quadrilateral, if opposite sides are one of the pair of opposite sides are parallel to each other, we call it trapezium. In a trapezium, if non-parallel sides are equal, we call it isosceles trapezium. Let's see, there is another situation that if trapezium becomes trapezium, it becomes like opposite sides are parallel to each other. In a trapezium, opposite sides are parallel to each other and they are equal. What it becomes, we'll see. So it's nothing but we can take directly from the quadrilateral. Also we can connect this to parallelogram. Also we can connect. In a trapezium, if opposite sides are parallel to each other, then we can call its parallelogram. Opposite sides of trapezium are equal and parallel. We call it as parallelogram. And in a quadrilateral, opposite sides are parallel to each other. Also, it becomes parallelogram. Trapezium also, we have opposite sides are being parallel to each other. We call it as parallelogram. And thirdly, if you take the quadrilateral, any quadrilateral, and opposite sides are parallel and equal, then we call it is parallelogram. So what we understood? Opposite sides are parallel and equal. If parallelogram, in a parallelogram, if each angle of a parallelogram becomes 90, if you take parallelogram and make each angle is equal to 90, then it becomes rectangle. And if all the sides of parallelogram are equal, if parallelogram, I have taken the parallelogram, if all the sides of parallelogram are equal, it becomes rhombus. All the sides of parallelogram are equal, not only the opposite sides, all the sides become equal, it becomes rhombus. And we can connect from the rectangle to rhombus also. Here, if opposite sides are equal, it's a rectangle. If all the sides of a rectangle are equal, it becomes rhombus. And if each side of rectangle is equal, that means all the sides are equal in the rectangle, then it becomes a square. In a rhombus, if each angle is 90 degrees, in a rhombus, each angle of a rhombus is 90 degrees, then it becomes square. So either rectangle, if we take all the sides became equal, it becomes square, or if we take rhombus, each angle of a rhombus is 90, then it becomes square. Then sometimes what happens is, with the four-sided figure, it's a quadrilateral in that it becomes kite, like in this form. So there are no opposite sides are equal, just adjacent sides are equal in this. So we have discussed about types of quadrilaterals. Let's recall. Quadrilateral, four-sided figure that if opposite sides are parallel, one pair of opposite sides are parallel, just one pair of opposite sides are parallel, we call it trapezium, and other sides are not parallel. And in a trapezium, if non-parallel sides are equal, this two are parallel and these two are non-parallel. If non-parallel sides are equal, these two are equal, then we call isosceles trapezium. There is another situation that in a trapezium, opposite sides are parallel equal, and because parallelogram is directly from the quadrilateral, opposite sides are parallel equal, it becomes parallelogram. And a parallelogram, if each angle is 90 degrees, then it becomes rectangle. In a parallelogram, each angle of a parallelogram is, each side of a parallelogram is equal. That means all the sides of a parallelogram are equal. All the sides of a parallelogram is equal. We call it as a rhombus. A rectangle, all the sides became equal, it becomes square. Each angle of a rhombus became 90 degrees. Then it becomes a square. And there is another situation, if adjacent sides are equal, we call it as a kite. So these are the types of quadrilaterals. Let's take quadrilateral. We have discussed about the diagonals of quadrilateral. If non-consecutive vertices are joined together, we'll call it a diagonal. If you join this both non-consecutive vertices, this two we have joined. So add this two, we'll get two diagonals. So these are diagonals of quadrilateral. Two non-consecutive vertices are joined. So we call it diagonal. So diagonals, two diagonals of quadrilateral. Here we have some of the properties of quadrilateral. If you observe in this quadrilateral, the length of the diagonals, we take ABCD, AC and BD are not equal. AC not equal to BD. The length of the diagonals in a quadrilateral are different or not same. That is AC not equals to BD. And we know the common property about the quadrilateral, sum of four angles of each. Sum of the four angles of a quadrilateral is 360 degrees. We know that is common property for all types of figures here, all the types of quadrilaterals. For every quadrilateral which is having the four sides, the sum of the four angles is 360 degrees. And here, and one more property there is AC not equals to BD. We have looked. The length of the diagonals are different in quadrilateral. Then after, let's see the trapezium. PQRS. It's a common property. We know that four angles, sum of the four angles is 360. It's common. And if we take the diagonals of the trapezium, this will not be equal. Diagonals of are not equal. Diagonals of trapezium are not equal. That is, PR not equals to SQ. And we find that the sides of trapezium are also not equal. And if you take particularly isosceles trapezium, the non-parallel sides will be equal in that. It's not an isosceles trapezium. That's the reason sides are not equal. Only just these are parallel to each other. That are PQ is parallel to SR. PQ is parallel to SR. So just these two lines are parallel to each other. The diagonals are not equal in this. And coming to the next diagram, parallelogram. We have learned about the parallelogram. Opposite sides are parallel and equal. We call it a parallelogram. Here, it's a common property for parallelogram. All the figures given for all. Sum of the four angles is 360 degrees. Sum of all the four angles is 360 degrees. And we take the sides of parallelogram in this. Opposite sides are parallel and equal. Let's write here. Mn is equals to PO and angle is equals to MP. So opposite sides are parallel and equal. Yeah. These two opposite sides are equal. And then there is one more property. Opposite angles are equal in a parallelogram. So angle N is equals to angle O, angle N is equals to angle O, angle P is equals to angle N. Opposite angles of a parallelogram are equal. Coming to diagonals of a quadrilateral, when we draw diagonals of it, the length of the diagonals are not equal in this, because the length of MO is not equal to PN and MO is greater than PN. So here what we can see that MO is not equals to PN. The length of the diagonals are different in this. So up to now what we have learned: quadrilateral, trapezium, parallelogram, and what we observe, it's a common property for all the three. It's sum of four angles is 360 and the length of the diagonals are not equal in quadrilateral, trapezium, and also parallelogram. So here all the sides are different, and here all the sides are different, and there is a difference between these three is the sides are not equal, but here opposite sides are equal. And coming to next rectangle, here opposite sides are equal in rectangle. Let's take the same name ABCD. AB is equals to CD and DC is equals to AD. Opposite sides of the rectangle are equal. And coming to diagonals of a quadrilateral, diagonals of rectangle are equal in this. So here you can write AC is equal to BD. The diagonals of a rectangle are equal. The diagonals of rectangle are equal. And we see the angles of rectangle. Each angle of a rectangle is 90 degrees. So we can write angle A is equals to angle B is equals to angle C is equals to angle D. Each angle is equals to one angle. So all the angles of a rectangle are equal, and opposite sides are equal, and length of the angles are equal. So we find everything is similar in this. Sides are equal, opposite sides are equal, diagonals are equal, and each angle is equals to one another. That is, all the angles are equal in this. So we found a different property among these all. So next we'll go to the square. It's a common property that all the angles of a square, sum of all the angles of a square is equals to 360 for all. This is common property, except that if you see, we know that all the sides of square are equal. All the sides of a square are equal. That is, if you take PQRS, then PQ is equals to QR is equals to RS is equals to SP. All the sides are equal like this. And if you observe the angles of square, Angle P is equal to angle Q is equal to angle S is equal to angle R. All the angles are equal and this. So each angle is equal to one another. All the angles of the square are equal. And then if you take the diagonals of square, the diagonals of the square are equal in this. AC is equal to B. Sorry, PR is equal to QS. The diagonals are equal in this.